All right, so we are on to the general process for superposition. We just learned what it meant to remove sources, specifically voltage sources. Just a real quick review. Voltage sources, when we remove them, they become a short, basically a wire. I draw the two dots so that you know a voltage source were there, but equivalently, it's just a wire. But I usually draw it like this just so we know a voltage source was there previously. And again, for a current source, we just replace it with an open circuit. Okay, so here we are, the first step for superposition. Let me go ahead and actually draw a circuit that we can look at. Probably just draw a real similar one to what I had previously. And then in the following slides/video, I'll just go ahead and solve this circuit for real with real values. But just for the overview of the process, let's get a look at it. So what I'm going to do is I'm first going to remove all but one source from the circuit. Doesn't matter which one I do first, but let's just say I wanted to remove the voltage source first. So then my equivalent circuit would be, I would replace my voltage source with a short, then I'd have my resistor, my second resistor, my current source, and then my last resistor, and this would be the circuit that I'm looking at. Okay. And so what does it say for step 2? So I removed all but one source from the circuit. I've got my current source here. And my second step is solve the circuit, the new circuit basically, for the node voltages or currents of interest. So let's say I want to find this voltage. I'm interested in Vx, okay? So this would be Vx with a subscript of 1 because I'm going to call this is basically my first sub-circuit in the superposition process, okay? So I've recreated the circuit without the voltage source, and I need to solve this circuit to find Vx1. I can use circuit methods, whatever I want to use. I can recognize that these two resistors are in parallel. I can recognize that I have, at that point, one series circuit with all my resistors in series and a current source. I know that my node voltage here is ground, so it's 0, and then I could determine Vx1. This is, again, just an overview of the process. I'll go ahead and solve this problem actually in the next video, but just want to give you an overview of the process. So let's say we go through, we do everything I just said, and we solve for Vx1. So that's great. We now know Vx1. Okay. And again, Vx1 is not equal to Vx. Vx1 is what Vx is if I put a short across my battery, right? That's what Vx1 is. It's not Vx yet. So then the third step says repeat 1 and 2 for each individual source in the circuit. So, okay, so now I need to go back to step 1 and remove all but one source from the circuit. Well, I already did the voltage source, so now let me do the current source. So my next equivalent circuit would be the same circuit, but I'm removing my current source, okay? And so I'm left with this circuit. All right. And so now let me go ahead back to this node that I'm interested in, and I'm going to call it Vx2 because this is my second equivalent circuit. Okay, and so now I would go through, use circuit methods. I could very quickly recognize this as just a voltage divider, and I could quickly solve for Vx2, and then I would have Vx2, okay? And so I said step 3 says to repeat steps 1 and 2 for each individual source in the circuit. Well, there were only 2, so we only have two equivalent circuits to solve, and we got our Vx1, we got our Vx2, and the final step here is to sum the results from each of the previous steps to obtain the final result. And so what does that mean for us? It basically means we found Vx1, we found Vx2, and if we simply sum them together, that gives us the original value for Vx that we were looking for, okay? And so that is superposition. We can basically split up our circuit such that we cancel out one source to start, then we cancel out the other source, and we solve those two equivalent circuits as if the other source was gone, just like we did. And once we do that, we can just sum up the results from those circuits, and we get the original value that we were interested in. Okay, that is the power of superposition. It basically makes a complicated circuit with all kinds of sources much, much simpler by removing all of the sources but one and having you solve them sequentially. Okay, so that's the general process for superposition, and in the next video I'll actually put values in and go ahead and solve this circuit.